In this video, we're going to review just a couple more topics in the first chapter, kind of wrap up chapter 1. So we will review the idea of a square root first, and then we'll look at just kind of the basic idea of graphing and what that looks like and how to create a graph. Let's start with the square roots and cube roots. So we have some general rules here that we usually use when we're dealing with square roots and cube roots. First rule is that every positive number has two square roots, the positive root and the negative root. Kind of flip-flop the order that I usually do these in. So let me skip down here to the square root, right? My definition is a square root is one of two equal factors. The word factor here means multiply. So if I can take a number and break it into two equal parts that are multiplied, the square root takes one of those two equal parts. For example, the square root of 25, right? I can break up 25 into 5 times 5. And so 5 would be the square root of 25. What we're saying here in the first rule that I've got written here is that I could also do negative 5 times negative 5. And that would also give me 25. So if we're saying it in words, we would say the square roots of 25 are 5 and negative 5. Okay, but we don't always talk about the negative 5, and so number 2 kind of addresses that. It says the radical symbol, that's the square root sign, denotes the positive or the principal root. So, you know, this sounds silly, but if you were to walk up to someone on the street and say, hey, what's the square root of 25? They would say 5, right? We're not really talking about both roots at that point. We're talking about the principal root. The reason or the place where both of these come into play is when we're solving an equation like x squared equals 25. And both of these would be solutions to this equation. We're just kind of giving a general introduction here. So it's good to know that there's something called a principal root. That's the positive one that we're used to seeing. It's also good to know that for a square root, a lot of times a positive and a negative could be a solution. We're going to get to that later on in the course. Another really important rule for a square root is that the square root of a negative number is not a real number. So I wouldn't be able to take the square root of negative 25, right? It doesn't work. I can't split negative 25 into two equal pieces that are multiplied. And because of that, I can't really take the square root of it. You could try it in your calculator. It'll give you an error. That's kind of a good reminder. All right. I also have up here the cube root. So it's similar, but now we're going to talk about the factors in groups of 3. So for a cube root, the symbol looks like this, with the little 3 out front. And that little 3 reminds us that we're looking for one of 3 equal factors. So since I can take 8 and break it into 2 times 2 times 2, right? 3 equal parts that are multiplied. The cube root of 8 would be 2. Something interesting about the cube root is that I can also take the cube root of something that's negative, like negative 8. Because I can break up negative 8 into 3 equal negative 2's that are multiplied. This is definitely based on the idea of multiplying positives and negatives. If I have an odd number of negatives, I get a negative. So the cube root will maintain its sign. If I have something positive inside, I'm going to get a positive result. If I have something negative inside, I'm going to get a negative result. in general, we could be a little bit more general and say, okay, I could have a 4th root, 5th root, 6th root, right? Any kind of root I want. If I want to use a variable, I could call it the nth root of a. All right, so that square root symbol, usually called the radical. Just to give you some names for these, the inside, whatever's inside, whatever that square root applies to, sometimes it's called the radicand, or I think I've seen more often it called the argument. So the argument of the square root is whatever. And then that little number out front, like the 3 for our cube root, is called the index. These may or may not come up. You'll definitely see the word radical again. You may see the other two here or there. Okay, so let's see here. Just to try this out, make sure we picked up on a lot of those things. These aren't meant to be difficult, just to kind of give you a chance to try them, right? So usually I would just ask you in class, but since I have no audience here, the square root of 49 is 7. Negative square root of 49. We're going to take the square root first and then apply the negative on the outside. So that would be negative 7. The square root of negative 49. We can't do that one. Right? So for now, we're going to say undefined. Later, we're going to say 7i. But we're not really there yet, okay? Unless you've seen this before. Okay, I always like to throw in a couple of interesting ones, right? I cannot break up a square root over addition or subtraction. So even though this is really tempting to square root the 9 and square root the 16, it is more appropriate to add these together first. So these would add up to 25. And then take the square root. It is not 3 plus 4, right? Or the square root of 9 plus the square root of 16. It is definitely not that. Okay, we just did the cube root of negative 8. Sorry, I spoiled that one for us. What about the cube root of 27 over 64? I can break up the square root over multiplying or dividing. So I could take the square root of the top, and the cube root of the top and the cube root of the bottom. The cube root of 27. 27 is 9 times 3, and 9 is 3 times 3. So that's 3 times 3 times 3. 64 is not always one you guys know, but it is 4 times 4 times 4. Okay. It would be wise to kind of look out at your calculator and see how to type it in. If you have a graphing calculator, the cube root is under the math button. I'm pretty sure it's choice 5. And then if you have a scientific calculator, usually you have something that looks like this. So you would type in, let's say you wanted to do the cube root of 27. You would type in the 3, you would push this button, and then you'd push the 27. All right, here's a couple of interesting ones. Find the side length S of a square with area 169 inches. It's area, right? So side times side would be side squared is 169. Okay, this is one of those cases where we could just think about what number would work for this if you want for right now. Eventually, we're going to take the square root of both sides. I'll go ahead and write that out. Now, normally I would put a plus or minus here, and this is part of where those two possibilities come, right? I'll go ahead and do that. So square root of s squared is just going to give us s. The square root of 169 is 13. So the positive answer would be 13, and the negative result would be negative 13. But since this is a measurement, this one doesn't really make sense. So really our best answer would be 13. Okay, same idea for number 8. Find the side length s of a cube with volume 125. So here's our cube. We have length, width, and height. So volume would be s cubed. Okay, you could think about what that would be. That's fine for now, like we said earlier. Or if you wanted to take the cube root of both sides, we're going to do that eventually. We don't have an issue with the signs for a cube root because we know if I start with a positive, I end with a positive. 125 is 5 times 5 times 5. So we'd have side length 5. All right. Let's take a look at just a quick recap of graphing. So we have what's called a relation, which is just a pairing of some numbers from two different sets. Usually we talk about x's and y's, but these x's and y's could represent anything. Right? X could be time and y could be population, right? So the population changes over time and we're kind of mapping that out. Okay, that's just one example. But we're pairing up, right? The domain is the word we use to represent all the set of x values in our relation. The range is all the y values. So here's an example of a relation. Here's 3 pairs, right? 3 ordered pairs. The first coordinates of each of them are the x's, so the domain would be just a list of all 3 x's we have. And the range would be the list of the y's. This time we have a y value of 4, 0, and 4. Since the 4 is repeated, we don't have to list it twice. Listing it once is enough. If you list it twice, it's fine, but this is the convention. Okay, this is a really basic review, so you may already have a pretty good idea of this, but I'm going to go through it anyway. This is our Cartesian coordinate system, right? The point in the very center is called the origin, or 0, 0, and the x-axis runs left to right, and the y-axis runs bottom to top. The positive numbers on the x-axis are on the right, negative numbers on the left. For the y-axis, positive numbers on the top, negative numbers on the bottom. Okay, so let's just say we wanted to plot these 3 points. So we've got negative 2, 4. So we start in the center. The x value tells us to go to negative 2. The y value tells us to go up to positive 4. We've got 0, 0. That's the one we said is called the origin. And then the last point is positive 2, positive 4. Now this is just a relation. There are no other points, so we're not going to connect them with a line or anything. We just have it's called a scatter plot, right? Just some points. Okay. Now let's actually graph an equation. This is just a general skill. We're going to talk more about lines and graphing lines in another video. So I have two different graphs here that I want to do with you. I personally really like to use a T-chart. I think that's the easiest for me to see. So I'm going to graph it that way today, and then I might add some other methods later, or you can bring in your own methods if you have those, especially for graphing a line. Okay, so when I graph an equation, I have a lot of options for x. This equation says, right, no matter what I plug in for x, this is going to calculate the y that's paired with it in this relationship. So I can pick any x values I like, right? To be convenient for your graph, it'd probably be good to pick numbers that fit on this grid. I could pick 25, but that'd be really annoying to graph, right? Okay, so I picked some x values here that might be convenient. To calculate the y values, I'm just going to take these numbers for x and I'm going to plug them into my equation. So for example, if I plug in -1, I'm going to have 2 times -1 minus 3, which would be -2 minus 3, or -5. And that's going to give me the y value, right? And I could do that for all of these. I don't know if you need to see them written out. You're welcome to write them out. You're welcome to do them in your head or do them in your calculator. Okay, so if I plugged 0 in for x, 2 times 0 would just be 0 minus 3 would give me -3. If x is 1, 2 times 1 would be 2 minus 3 would be -1. If I plug in 2, 2 times 2 would be 4, minus 3 would be 1. And then I can plot those. Okay, right now I'm not going to really give you a whole lot of expectations as far as, we haven't talked about the shapes of the graph at all. We will, but for now I'm just going to tell you that this is a line. Okay, so all of these points should line up in a straight line. Okay, so let's plot them. So I have -1, -5. 0, which means I don't go left or right, -3. That's a special point called the y-intercept. 1, -1. And 2, 1. Okay, and so because it's an equation, these are 4 example points, but all of the x values, all of the real numbers on the x-axis here could have been plugged into this equation and given us a y value, and so when all the numbers are there, we draw the line. All right, let's try one more. Okay, likewise, I'm not going to expect you to know this yet, but we'll talk about why this is later. This shape is a parabola, which is sort of like a bowl shape. So when I plot these points, I should get a shape that sort of looks like that. Okay, and I'm going to plug them in. Let me squeeze that into the bottom this time. So if I plug in -2, it's not a bad idea to put parentheses around a negative number when you substitute it in. So -2 times -2 would give me +4. And 4 plus 2 would give me 6. Okay, and I could do that same thing for all of these. Again, you're welcome to write that out. Do it in your head, do it in your calculator, whatever your preference is. -1 squared would be 1. 1 plus 2 would be 3. 0 squared would be 0 plus 2 would be 2. 1 squared would be 1 plus 2 would be 3, and then 2 squared would be 4. 4 plus 2 gives us 6. We see some repeated values, and that's kind of based on the shape here. So I have -2, +6, -1, +3, 0, 2, 1, 3, and 2, 6. Again, because I'm graphing an equation, these 5 points are just example points to help me draw the curve. But I could pick any numbers in between or around these points, and that would fill out the whole line that I've drawn there, the curve of the parabola. All right, I hope this gave you a kind of a basic idea. This rounds out chapter 1 for us, so we'll be moving on to chapter 2 in the next video. Good luck. We'll see you next time.